So in this lecture, we'll talk about loops, looping, and control constructs. So looping is basically doing something over and over again in your code. It happens all the time. There are many times you want to go through an array and evaluate it. You just do whatever the process is over and over. Actually, in Arduino, that's implicit in an Arduino is that whatever you're executing, you do it over and over and over as long as the Arduino is powered on. So loops are an important construct, and we'll talk about the different ways to do loops in C. So we got two basic kinds of loops: while loops and for loops. We show three examples up here. There's a for loop at the top, for loop up there, then there's two while loops. There's a while loop on the left, regular while loop, and then on the right there's a do while loop. It's got a do at the top and a while at the bottom. So generally with any kind of loop, regardless of what kind of loop there is, there's always going to be some kind of an initialization step, okay, and some kind of an increment step and some kind of a conditional check. So every loop has to have some end condition, some kind of condition that notes that that tells you that the loop is done, right? So you usually don't want to loop forever. Actually, in Arduinos you do, but we'll get to that next course. But often you don't want to loop forever. Maybe you only want to do this thing 100 times, right? So you need to be able to check, have I done this 100 times, right? So there's always going to be some sort of a conditional check associated with a loop, where you check, has this been done 100 times? Now, the most common way to check a thing like that is, say you got a variable, you have some variable which just tells you how many times you've been through the loop. So like I is a typical name for that variable, I for index. So say you want to go through a loop 100 times. At the beginning of the loop, you'll set that I equal to 0. Then every time you go through the loop, I say I++, incrementing I. Then, and every pass of the loop, before you start the loop again, you want to check, is I still less than 100? If I is less than 100, then you do the loop again. But eventually I isn't less than 100, and then you're done with the loop. Okay? Now that's what's going to happen if it's a for loop or a while loop, either one, basically that's going to happen, right? There's some kind of a check for the end, for the termination condition. Okay? Now, and often that's just using an index variable and adding 1 to it every time, but you can have much more sophisticated conditional checks at the end for termination if you want to. So now the conditional check at a for loop and in a regular while loop, the conditional check is checked at the beginning, right, to see if you're done with it. So if you look in the for loop, expression 2, EXPR2, that is actually the conditional check, right? And I'll give you an example of that, but that's the conditional check, and you do it at the top of the loop. The while loop, the first while loop on the right, expression 2, again, is the conditional check. If that condition is true, then you execute the loop. If it's false, you skip the loop, and you're done. Now, in the one on the right, expression 2, again, is a conditional check, but notice that it's at the bottom of the loop. So what that means, the difference with that while loop on the right is that it always goes through the loop at least once, because it doesn't do a check until the end of the first pass of the loop. So the difference between those two while loops is just where you do the conditional check. Do you do it at the end of an iteration of the loop or at the beginning of an iteration of the loop? And the difference happens with the one where you check at the end means you always have to go through the loop at least once. Where with the one where you check at the beginning, you might not even go through it the first time if the condition isn't true. So let's take this while loop. There's a main statement, a main function, and then before we even get into the while loop, you first define a variable called I and set it equal to 0. So I is going to be our index variable, and that's going to tell us how many times we've been through the loop. This is a very common thing to do in these loops. Now, you'll notice a while, in parentheses, it says while I less than 3. So what this is going to do is execute this while loop 3 times. So I starts off as 0. And then inside the loop, you'll see it does a print statement, a printf. It prints the variable I. And then it says I equals I plus 1. So every pass of this loop, I is incremented. So the first time through the loop, I is equal to 0. The next time through the loop is I is equal to 1. Next time through is equal to 2. Now then it becomes 3. So then you get back to the top, and it says while I less than 3. But if I is equal to 3, then that's not true. So it finishes the loop at that point. So this loop will actually execute 3 times. When I is equal to 0, I is equal to 1, and I is equal to 2. Once I is equal to 3, it exits the while loop, and it doesn't execute a final time. So this while loop, after the word while, in parentheses, you have the termination condition, right? The condition that is checked at the beginning of every pass through the loop. Now, A for statement actually is a little more structured than a while statement, right? Now you notice how the while loop, it had the termination condition in the parentheses. So the for loop, if you look at its parentheses, the parentheses after the for, so for and then there's open paren, close paren, there are actually 3 statements in there, separated by semicolons. Now the middle statement is the termination condition, just like with the while loop, I less than 3. The first statement is the initialization condition. So that tells you what you want to do just right at the beginning, the first time you start this loop. I equals 0, assigning I equal to 0. Now notice with the while loop, that wasn't built into the while loop. So we had a statement before the while loop that said I equal to 0. But with the for loop, that's built right into the for loop. The first statement inside the parentheses is the initialization. Then you got the termination, that's the second statement. And the third statement is the step, the increment. So I++. So what that does is that third statement is executed at the end of every loop. So every time you execute the loop, it automatically does I++, incrementing it. Now notice in the while loop, we also incremented, but we had to make it explicit. We as a programmer, we had to write I equals I+1 as a statement inside the loop. With the for loop, you don't have to do that. It's just built into the structure of the for loop, that I++, that last step at the end. So this loop right here does the same thing that the while loop did on the last slide. It just does it with the for loop instead. And notice that the initialization, the termination, and the step, they're all built into the for loop, unlike with the while loop where the termination was built into the while loop, but the initialization and the step had to be put in manually by the programmer. One other thing about break and continue. So actually we looked at break already in the context of a switch statement. But break is also used in loops. It does a similar thing inside a loop, and also there's a continue statement. So let's look at break first. What a break does is it just exits the loop. So if you ever execute a break, it jumps out of the loop. So if we look at our while loop at the top, the first one, while x is greater than 5, y++, and if y is less than 3, then it breaks. So even though you might not be done with the loop, maybe x is still actually, this is sort of a messed up loop, but ignoring the content of the loop. Let's say this loop, we wanted to go through this loop 100 times, right? And x is going to be greater than 5 100 times, right? But it doesn't matter, because if you hit that break statement, if y is less than 3 and you hit that break, then you jump out of the while loop, regardless. And it kicks you out. And so you don't execute, it's sort of it preempts the termination check. It's like an early termination is what a break is in terms of a loop. Now continue is a little bit different. Continue, when you hit the continue, it doesn't jump out of the entire loop. It jumps out of that one iteration and moves to the next iteration. So in the example that we have below, we replace the break with a continue. So what happens is if that continue is executed, it doesn't jump out of the loop. It goes back to the top of the loop. So what that effectively does in this case is everything in the loop after that continue is not executed on that pass. So in this loop, you see there's an x++ after the continue, right? On the pass where you execute continue, that x++ is skipped, right? And the loop goes back to the beginning, right? So it stays inside the loop, but just goes to the next iteration of the loop and skips whatever the remainder of the loop is. Thank you.